Alright, for this little video, we're going to take a look at a couple of algebra problems. We're only going to do two different types of problems. The first problem I'm going to do twice. The first time I'm going to do according to the essentially 5-step, I call it a 4.5 step because it depends on if you have to clear fractions or not. But a process that you can follow and do linear equations all day long. The next one I'm going to show you the difference between knowledge and how to do this and understanding and why this works, because the why it works allows you to do some other funky things that might actually be easier in the long run. So here we go. My first step is going to be to distribute. That's always my first step if I can do it, unless of course I'm doing it the next time. So I distribute this through. This 1/2 multiplies through and gives me 2 minus 4x. And that is equal to, now here's where the sad part comes in, is when I throw the 1/3 through, the 1 multiplies the 4 and the 7, the 3 divides it. So I can just write this as 4/3 x plus 7/3, and then I'm going to subtract 3. Okay, at this point, some people will choose to combine the 7/3 and the -3. I don't. Because if I'm going to go ahead and make this easy on myself, I'm going to make it easy. So what I'm going to do is I'm going to go ahead and I'm going to multiply. This is declaring the fractions now. I'm going to multiply both sides by the least common multiple of all of the denominators. In this case, I only happen to have 3, so I just multiply everything by 3. Everything. Both sides. So here we go. Now when I multiply the 3 through the fractions, it's going to come in on the numerator. So that's effectively going to cancel out my denominator. That's why it's going to look as easy as it does. 3 times 2 is 6. 3 times -4 is -12x. 3 divided by 3 is 1 times 4 is 4x. Plus, and then we have 3 divided by 3 is 1 times 7 is 7. And then 3 times -3 is -9. Now that I've got all my fractions out, I go ahead and I look to combine things that I can. And I do this on each side separately. So I notice that now I can combine these two things, and life is good. So 6 minus 12x is equal to 4x. A positive 7 minus 9 gives you a -2. Then I start moving stuff around. I am going to choose. Now this is, you can do it however you wish. I know that eventually when I teach my students, I'm going to teach them how to work with inequalities. And when you are working with inequalities, if you have to multiply or divide by a negative number to solve, then you need to flip the inequality along with all of the signs. If I make my initial variable positive before I have to multiply and divide, I don't have to do that rule, so I don't have to remember it. That's why I'm choosing to move the 12 over to the right-hand side. If you were going to go ahead and subtract 4, go ahead. It's fine. No big deal. That is going to give me a 6 over on the left, a 16x plus, not plus, -2 on the right. And then I'm going to add 2 to both sides. That's going to eliminate, leaving me with just 8 is equal to 16x. And then finally, I solve. So I'm going to kind of bring this up here because I have another problem right under it and I don't want to scroll down. My 8 is equal to 16x. I'm going to divide both sides by 16. Now clearing the fractions does not change the answer. So if the answer was going to be a fraction, you're still going to get a fraction. And in this case, 16s cancel. We get x on the right here, and then we get 8 over 16, which reduces to 1/2 on the left. And it's just step by agonizingly painful slow step. So keep that in mind. Just as you're working through it, right down the list. All right, same problem. I'm going to do it a slightly different way. And I'm going to choose this way because in my mind it was faster and easier. It's entirely up to you. Alright, exact same problem. Now, I'm going to distribute, but I'm not going to distribute everything everywhere. As I notice over here on the right, I see the 1/3. If I were to distribute that, I would have fractions. I'm going to choose to not distribute that. I am, however, going to distribute this 1/2. That's going to give me 2 minus 4x, just like it did before. Only now I have this. And then, just to show you that I can, I'm going to add 3 to both sides. Gives me 5 minus 4x is equal to 1/3 times the quantity 4x plus 7. Again, initially, I told you that, hey, I'm going to go ahead and distribute everything. Again, this is just a guide. It's not hard and fast. So I moved with the blue. I am going to multiply with the orange. And I'm going to choose my multiple to be in such a way that this gets canceled out as far as a fraction goes. If there happens to be something left on top other than 1, I'm okay with that. So I multiply all of this by 3, being extremely careful. Notice that I have a number here. That whole mess being contained within parentheses is one single number. So I'm saying take 1/3 of that number. So if I were to say multiply, just kind of over here on the side, if I were to say multiply 1/3 y times 3, you would only give the 3 to the 1/3 because you don't distribute multiplication over itself. You choose which multiplication you want. That's the associative property. Also, rearranging, which would have to happen here, would be the commutative. So 1/3 of 3 is just simply 1y, which is just 1. Okay, now, I'm sorry, which is just y. Now look at the structure of it. It's 1/3 of something, 1/3 of something, times 3. The third gets the 3. So over on the right side, the third gets the 3, and that cancels out, leaving us with just 4x plus 7. The thing. Maybe if you start calling it the thing, it might actually be easier. I don't know, maybe. But our 3 does have to go ahead and distribute over to that other left side, and it has to distribute through all the terms. So this is going to be 15 minus 12x. Already you notice it looks different. It's not going to look different when we're done, but you know, that's fine too. Now I'm going to go ahead and I'm going to move stuff around again. So I'm going to be doing this step 3 but in green. I'm going to go ahead and I'm going to move my 12x first, just like I did before for the same reasons. That's going to eliminate, leaving me with 15 is equal to 16x plus 7. I'm also going to use my purple here, and I'm going to subtract 7 from both sides, moving all of the non-variable terms to the other side, giving me 8 equals 16x. And finally, just as we did before, I'm going to solve it using my red. So I divide both sides by 16, leaving me with just 1/2 is equal to x. Okay, so now you might look at it and be like, you know, it took a little longer that way. It took longer not because it was harder, for me at least, but because I wrote it all down. 3/4 of this stuff, because of the way I chose to do it, I did it in such a way it was easy for me to do. I could do it in my head. So in a way, this particular method would be faster for me. It's not always true for everybody. The more you know, though, the more you get to choose. Okay, last one here. It's a blank one. I'm going to pause and put this in. Okay, so I had to take a moment and reinsert the thing because apparently I didn't do it right the first time. But here we are. Same idea, same steps, nothing's changed. Now, instantly somebody's going to be like, "Oh, what if that was an x squared?" Okay, that whole thing changes. This is just for linear, just for an exponent of 1 on the x. That's it. But what if it's y? It's the same thing. But what, shh, it's okay. It's the same thing. Distribute. So that's going to give you 3 times x is 3x minus 6 plus 4x. Nothing happened to that. Over on the right-hand side, I get 6x minus 6, and then plus x. I've been allegedly doing this for the past 25 years. I will still write down my distribution arrows or arcs or claws, however you want to refer to them. It's just a note to myself. I want to make sure I don't forget anything, so this helps me not forget anything. There is zero wrong with it. There are no fractions. Skip it. I need to combine on both sides. All right, so I've got a positive 3x and a positive 4x, which gives me 7x, and a negative 6 comes down. Over on the far side, I have a 6x and a positive x, and that's going to give me a 6x minus 6 over here. At this point, some of you may be like, okay, I know what's going to happen. Others might not see it, so we're going to just let it work. I'm going to move my variables first. Let the math do the math. Don't try to force the issue. Many people force the issue in this sense and don't trust the math. You might not like the answer. That's not math's problem. 7 minus 7 is a 0x minus 6. I'm going to clean that up in just a bit. 7 minus 7 is a 0x minus 6. But 0x is just 0, so I'm left with negative 6. 0x is just 0, so I'm left with negative 6. I now have a statement that reads that negative 6 is equal to itself. More importantly, you'll notice the lack of an x term on either side. You're not wrong. What this is telling you is that something bad happened and that the answer doesn't actually depend on what number you make x be. So, this is a true statement. This particular equation states that you have an identity. My dog just dropped a shoe or something outside. You have an identity happening. That means that if I go back up to my original equation, I can put any number in for x. And it's true. Because remember, if we go back to the previous examples that we did, we got 1/2. Well, that's called a conditional statement. The equation is true if x equals 1/2. Well, what if x equals 2? No, you didn't satisfy the condition. We have no idea if it's true or not. All we know is that, hey, if it's 1/2, it's true. That's it. This is saying, I don't care what you put in for x. It's true. Always. X is completely irrelevant in this case. So, there's another way that this happens as well, but it doesn't happen nearly as nicely. I'm not going to go through an entire solution for it, but if you were to go through a problem and you get a statement that says something like this: -3 is equal to 2. This is a false statement. This is known as a contradiction. This means that there is no value of x or your variable, whatever variable you have, that will make your initial equation true. Makes equation true. So what happened is, somewhere up above you said something equals something. This is telling you that's false. Those two things cannot actually be equal ever for any reason. That's what it's telling you. This is actually a really, really, really good method of proving things in higher mathematics. We might not be able to prove the way that I term it is anyway. You might not be able to prove the positive. So like if oh, I don't know. If you have a right triangle, then you have the Pythagorean theorem, a squared plus b squared equals c squared. You have that. Okay, so you can't prove that. For whatever reason, you can't. But if you could show that when you can't have a squared plus b squared equals c squared, so a squared plus b squared does not equal c squared, then you can make the logical jump that you don't have a 90 degree. So sometimes, and that's called the contrapositive. Sometimes it's easier to prove things in the negative. This would be like, say, I'm assuming that it's not true, and then I show that that can't happen. That's the weirdness in it. So that's what a contradiction is. Well, I hope this helped. Again, remember, take your time, go through the process, let the math do the work. Thanks for watching.